Our next speaker is the person that we have to thank for this lunch, actually. This lunch is sponsored by Penguin Computing, and they make it possible for us to have this great meal, so it's fitting that we have Arend Dittmer here from Penguin Computing to talk to us about their solutions.
I was saying I talked to my friend Jess Arrington earlier, and he said if you present over lunch, make it really quick or make it really funny. As I'm German, we're not the funniest bunch. I'm going to make it really quick. Okay, so I'm going to talk about our HPC public cloud, Penguin Computing on Demand. Acronym is POD. Before I get into the specifics of cloud computing and HPC, I want to talk a little bit about the company. Penguin has been around since 1998. We have about 2,500 customers in the typical HPC industry verticals, national labs, defense, life sciences, enterprise, a lot of universities, so we're across the board. Our focus is Linux and HPC, and has been since '98. So we have a broad range of products that we have. So we have Linux systems, rack-mounted servers, storage, interconnects, GPUs, you name it, and we also integrate all these components into turnkey clusters. What helps with that is that we also have our own cluster management software called Skilled Clusterware. That is basically the software glue to hold everything together. And of course, when we talk about turnkey integration, we do in-factory integration with our professional services team, and then we can help with on-site deployment, rollout services, training, product support, GPU consulting if that's something you need. So we basically have the full offering. I want to focus on the second last column there, the HPC Cloud services now. So our Penguin Computing on-demand offering up to this point, 15 million jobs have been pushed through Penguin Computing on Demand. And you see here a small list of customers for you in the back that can't read. Earthmine, University of North Carolina, Dolby Laboratories, Honda, Nissan. So we have a large list of marquee customers that are really realizing the benefits of HPC cloud computing and are using Penguin Computing on Demand. I want to talk a little bit about the resources that we offer. So basically, Penguin Computing on Demand is a shared infrastructure that's accessed through dedicated login nodes. So every user of Penguin Computing on Demand has a dedicated login node. There's, by the way, no charge for these login nodes that he can log into from a specific IP address or range of IP addresses. These login nodes are relatively simple because the resources that they provide are relatively low because they're typically just used for pre-processing jobs and then for job submission into the main cluster environment, into the actual Penguin Computing on Demand environment. Where we have a bunch of current Xeon and Opteron processors with 2 gigabytes of RAM per core. We actually use Moab as the scheduler in this shared compute infrastructure. And as I said, access is through the virtual login nodes. There is a shared file space between the compute nodes and the login nodes, and then end users actually submit the compute jobs once they have done the preparatory work for these compute jobs from the login node, and then Moab handles the placement of these compute jobs on execution nodes. By the way, for security reasons, it is a shared environment, but we make sure that we never ever run jobs from different customers on the same system. Okay? So whenever you submit a job, you know that it's running on one system that you have for yourself. The nodes offer direct attached storage. We also have InfiniBand interconnects, 10 gig interconnects, and gig E. That's important here in regards to the comment that Chris made, that cloud environments are often not ready for HPC applications. So in our environment, because it has been built specifically for high-performance computing, the nodes are tightly coupled. We have low latency interconnects, so you can run distributed applications with good performance on Penguin Computing on Demand. The nice thing is, because it's a shared infrastructure that scales on a job-by-job basis for individual jobs, that you really don't have to allocate application instances, node instances there is no fixed allocation that you have to change when you want to scale out. So you can submit a job that runs on, let's say, 8 cores, and then you can go to 64 cores in the next job, or 128, or whatever your scalability requirements are. So scalability is on a job-by-job basis, and you're only billed for the resources that you use. Again, per core, per job, and we bill up to 1,000th of a core hour. So the granularity of billing for the resources you use is really in the order of seconds. 1 to 600 cores are available for one job on demand. We have, as I said, direct attached storage, and we currently have 3 locations for Penguin Computing on Demand: Salt Lake City, Mountain View, and we have a joint collaboration with Indiana University for academic customers. Commercial applications we provide. This is just a small list of applications that we have out of the box. Of course, if you want to deploy your own applications, our engineers are ready to help you. By the way, that's one thing we take great pride in, is that we provide the hand-holding. It's not just, here's a compute resource, good luck using it. We actually help you deploy applications. If you want to install something non-standard in your home directory, or you need us to install something in a specific directory, our services team works with you, and these services are, to a degree, of course, included in the pod pricing. This testimonial actually outlines 2 things that we take great pride in. First of all, that it's, or actually 3. First of all, it's a scalability. As I mentioned, we have dynamic scalability on a per job basis. So it's very easy to scale up without having to allocate virtual machine instances. The service is very cost effective. And the other thing is along the lines of the comment that I just made, that we're more than just a provider of cycles. We actually provide application expertise that we make available to our customers when needed. So in this case, we help this customer really with a 4x performance improvement with his codes, actually, because our engineers observed an inefficiency, pointed this out to the customer, and he was able to fix his code. So he saw us more as a collaborator than as a vendor, which we're very happy to hear. So as I mentioned, we've run 50 million commercial jobs through Penguin On Demand by now. I just want to touch on a couple of customer cases here. Earthmine is a company. They do something really cool. It's, in a way, I call it Google Street View on steroids. So they provide, or they capture 3D imagery of street views, and every pixel in the image actually encapsulates all 3 spatial dimensions. So what that practically means is, when you look at one of their images, you can draw a line in the image, and you can really get the spatial distance between the 2 points that you're pointing to, the starting point and the end point of your line. So it's very, very interesting for municipalities, for example, that do a lot of inventory management through the software that Earthmine provides. They have a pilot with Yellow Pages in France. And as you can imagine, an image that encapsulates complete 3D information, to process that is very resource intensive. So they have these cameras. You see one here mounted on this car. It's actually 8 cameras, and each camera takes a shot every 50 meters that this car drives down the street. And all that image processing and encapsulating all that image information into one 3-dimensional image that they provide, that's done exclusively on Penguin On Demand. So these guys actually scrap their own cluster, and they're only running on Penguin On Demand, or this image workload. Another customer is Life Technologies. Life Technologies is a leading provider of genomic sequencers. Again, genomic sequencers, particularly the ones that are called next-generation sequencers, produce massive amounts of data that has to be post-processed. And they are offering Penguin On Demand to their customers actually through a portal that looks like it's their product. So they're rebranding the Penguin On Demand offering and make that available to their customers. Caltech replaced Amazon Web Services, Amazon EC2 with Penguin On Demand using pod tools. I have a slide on that following this one. And then we also have been getting a lot of Japanese customers, in particular in the car manufacturing area. And that's related to the problems that they're having in Japan following the tsunami still. They still have brownouts in Japan. And in order to get simulations done and get the job done, they're basically moving to on-demand infrastructure such as pod that are outside of the country to get the throughput that they need. PodShell, I just mentioned that this is actually a very interesting tool that makes it easy to access pod from any system through a firewall. So it's based on a web service, and it allows you to submit jobs into Penguin On Demand without having to log into the login node. So we run a web service, and with PodShell, you can actually submit the job, and not just submit, also do the data staging, so that your files are uploaded, the job is run, the files are downloaded, all that with one single command from any system. So what you do is you basically enter your pod credentials into a static file, and then you can run these commands and you're good to go. We also have commands, of course, that allow you to monitor the status of your jobs and what they're doing in pod. And this could also be interesting in synergy with Moab. If you're interested in building cloud bursting, you can implement a forwarding queue that your users use when all the local resources are used up, so that compute jobs are forwarded to Penguin On Demand through PodShell, but the Moab monitoring commands would still show the job as running. So it's a simple way to provide transparent cloud bursting, so to speak. So in summary, the advantage of pod is that it's been built for high performance computing. So we're looking at a bare metal computing environment. We have low latency interconnects to enable you to run latency sensitive distributed applications. Unlike other offerings, it is really built, it is an HPC infrastructure that was then turned into public cloud. So our business model is not to make access, to somehow sell access cycles. The business model is to provide HPC specific resources. Fast access to local storage. As I said, we have direct attached local storage. It's a pure pay-as-you-go model. So the only thing you pay for is the core hours that you use and the storage resources that you use. So even this virtual login node that's dedicated to you that provides the access, we don't charge for that. HPC expertise is included. That's along the lines of the quote that I showed you. So HPC is our bread and butter. We make that expertise available to our pod customers. And as I said, within the limits, we do that free of extra charge. Troubleshooting is included, and we have the dynamic scalability. Again, we don't rely on instance allocation. You can really, with every job, you specify how you want to scale that job. And it can be 32 cores in one job and 128 in the next, and 640 in the one following after that. And you only pay for the resources actually used. That was it. So if you have any questions, just grab me. We have a table out there. I'll be hanging around. So thank you very much for listening.